Good evening, everybody. How are you all doing?
Fine, so.
Okay, so everyone, you all can respond.
Fine, sir.
Good. Okay, nice to hear that. And today, actually, we have many people joining us on YouTube as well. So to all of them as well, very good evening and welcome to this session. So first of all, let me introduce myself before we proceed ahead. I'm Abhilash, as you already know, and I'm the head of the Department of Physics here at the askIITians. And past more than 6 years, I'm teaching students for entrance exams like JEE Advanced, Mains, NEET, and for foundation grade students, I train them for the Olympiads. Many of us have already met. We know each other. Some of your name I already remember. Some of you are new for me. So we can have a very quick intro from you guys. How about that? Even our friends on YouTube will be able to hear you. So that will be great. So let's go one by one. Let's give a quick intro to everyone. Okay. So let's begin one by one. How about if we go with alphabetical order? Aditi first. Aditi, you can introduce. Hello, Aditi, can you hear? How about Akhil? Akhil Ahmed.
Good evening, sir. Myself Akhil Ahmed, and I'm currently in Saudi Arabia, and I'm studying in International Indian School Al Jubail.
Okay.
My native place is Tamil Nadu.
Okay, and what do you want to become in future? Akhil?
Engineer, sir.
Engineer. Okay, great. We'll go next to Ankit. Ankit Amin.
Yes, sir. Good evening, sir. I am Ankit Amin from, I am living in UAE, Dubai right now. I go to Delhi Private School, Sharjah, and I want to be a computer engineer in the future.
Okay, that's really great. Let's go to the next person. So we have Arnav.
Good morning, sir. I'm Arna from Indian School Al Gubra.
Okay.
I currently live in Muscat, and my hometown in India is Delhi.
Okay, that's great. And what do you want to be in future?
Sir, engineering in artificial intelligence.
Okay, engineering and artificial intelligence. Okay, great. Let's go with the next person, Jay and Jainil. Both of you can introduce.
Yes, sir. So we are from Gujarat, India, and presently we are living in Saudi Arabia, Al Jubail.
Okay.
And we are here since 10 years maybe.
All right. Okay. And what are your hobbies and aims, Jay and Jainil?
Our hobbies are to play outdoor games, and our main goal is to become mechanical engineer.
Mechanical engineers. Okay, great. Let's move to the next, which is Jayesh.
Good evening, sir.
Good evening.
So this is Jayesh Kumar. My originally from Punjab. I'm currently staying in Muscat. My hobbies are to play sports and do some listening to music and spending time like this. And till now, I haven't decided what to become in future, but my main aim is to crack JEE.
Okay, great. Let's go to the next person, which is Karthik.
Good morning, sir. Myself, Karthik Anand Purandare. I am currently in Nagpur. I want to become a software engineer.
Okay, nice. Let's go to next, which is Kishore.
Sir, I am Kishore Kumar from Oman, and my native place is Tamil Nadu. And I want to become mechanical engineering.
Right.
And my hobbies are to play chess and cricket.
Okay, nice. Next is Nitushri. Okay, no issues. Next, Shivang's mic not working. What about Shreya now?
Good evening, sir. I'm
evening.
Shreya. and I'm from Odisha, but I'm currently in Jubail, Saudi Arabia. And I want to become an astrophysicist.
Okay, astrophysicist, great. And next is Siddharth.
Hello, sir. I'm Siddharth. I'm living in Riyadh, Kingdom of Saudi Arabia. I have interest towards software sector.
All right. And last, Vedant. So guys, please interact video wise also. We'll be able to interact in a better way. You guys can switch on the cameras. So yeah, next Vedant, you can go ahead.
Hello, sir. I'm Vedant. I'm currently living in Indore, Madhya Pradesh, and I have not yet decided in which engineering field I have to go, but my goal is currently now to crack JEE exam.
Okay, great. Nice. Now let's go to the actual part of the class we all are waiting for. So obviously all of you now have entered 11th grade, and this is a major challenge from whatever you were learning before, because just now you have cleared your 10th exam, and the major challenge you will be facing is a complete change from the previous grade to the current grade. Why I call it as a complete change, you can see it from the syllabus itself, the amount of syllabus that you learn. Take for example, in 10th grade in physics, how many chapters were there? 4, right? Hardly 4 chapters were there. But in 11th, you will find that the same number of 4 chapters now suddenly switch to 18 chapters. So this is a challenge that one has to meet. Okay, sudden increment in the syllabus. The second challenge anybody has to face is a sudden increment in the level. Now you'll be learning for JEE, isn't it? JEE is not a joke, honestly speaking. JEE is the world's toughest entrance examination at +2 level, and that is recognized by every good university around the world. So I have told you before also, some of you are already there with us from a long time. They're associated. I know all of you, most of you personally. So I've told you this multiple times also, that even foreign universities like MIT, Harvard, Oxford, they absolutely welcome students who have scored good rank in JEE Advanced, especially among the top 10. All right. So that is something you can gather about the reputation of the JEE Advanced exam. All right. Yes, we'll have more and more people joining now. Don't worry about that. So more the number of people, the more good it will be. Now we are about to start, guys, 11th topic. And the topic we are learning today is motion in 1D. Okay, motion in 1 dimension. So let me share my screen and let's start dealing with this topic. Okay, so have you guys heard about this topic? I'm very much sure you all have heard about it. Motion in 1 dimension. When did you learn it last time? Anyone? 9th grade? Do you guys remember? Yes, 9th grade, you have learned motion in 1 dimension, isn't it? Now, this is something you will going to see over here, that in 9th, what we learned is actually called as classical mechanics. So if I write here the learning from your 9th grade, in physics category, it's called as classical mechanics. Because what all you learned, think about it. You learned about motion, you learned about forces, you learned about sound, isn't it? How sound is produced and all those things. All that falls under classical mechanics. And look at what you learned in your 10th grade. In your 10th grade, you had electricity and magnetism, isn't it? Also about light. Everybody agree with this? So this part of 10th is actually called as electromagnetism. So these are the 2 major things you learned in your 9th and 10th grades, classical mechanics and electromagnetism. The best part is the same 2 units of physics will come back. They will come back again now in 11th and 12th. So suddenly when you will going to see your 11th grade syllabus, you will realize that 11th grade syllabus of physics is all about classical mechanics. And the moment you will going to later see your 12th grade syllabus, it'll all be about electromagnetism. So you might be like, so will we be repeating the grades we have already learned? No, it's very wrong to call it a repetition. Reason, because you'll be learning it in much more depth. What you learned just in 4 chapters in your 9th, the same will be now expanded all the way to 18 chapters. So why such expansion is happening? Because we will be going in more and more detail now. All right. The moment detailing increases, then the understanding also goes really deep. Okay, so this is something you're going to enjoy if you love the things around you. If you love the science, you're going to love this. So motion in one dimension is essentially something we'll be discussing today in today's class. Whenever you hear the word motion, what all terms come to your mind? So everybody be interactive. Don't be such.
Sir,
Yeah.
sir, for today's class, the link is not available on the portal.
No, it is there.
No, so for me it is showing 21st April directly. 20th April it is not showing, sir.
Yes. So that doesn't matter. Right now we can do whatever we are doing. We'll see that point of time also. Okay. So guys, come back to this point, what I'm saying to you. What comes to your mind when you hear about motion?
Movement of a body.
Movement of a body, isn't it? Everybody? Others,
Yes, sir. Yes, sir.
What all terms come to your mind? Please list down
Velocity,
the terms.
distance, speed.
Velocity, distance, speed, moving from one place.
Displacement.
Correct. Acceleration, displacement, all these terms come to your mind. Others also agree with the same? They also get in their mind the same terms?
Sir.
Yes. So you're absolutely right. The basic things that we first of all get is distance and displacement. Yes, Vedant is right. You also hear about momentum. But the most basic terms that you hear is about distance and displacement. All of you already have a vague idea about distance and displacement because they are very basic concepts, isn't it? Distance and displacement. What is the difference between distance and displacement? If I ask you all, how will you put it up?
Distance is the path length, and displacement is the body changed from its initial position to final position.
Okay. Others also agree the same definition?
Distance is always positive, but displacement can be negative, 0 or positive.
Okay. Anyone else with any other definition?
Displacement is a vector while distance is a scalar.
Yes, absolutely.
Distance only depends on magnitude and not direction.
Correct. That's what is covered in.
Is the shortest distance between any 2 points.
Correct. That is also a correct definition. So all of the things that you have told are absolutely right. And we can understand it in this simple example. Suppose when I tell you that you are starting from A and you have to finally reach at B. Let's say right now you're sitting at your home and you have to reach a nearby place. Let's say a mall, a shop you have to go to. So what you do if you don't know the road, you immediately put it into the Google Maps. The moment you do that, Google Map shows you the way to reach there. And you must have seen most of the time there is not just one way to reach there. There are always multiple ways to reach there, isn't it? There may be a road shown by Google Maps, which might be like this. And there may be another path shown by it, which might be little lengthier. And you must have seen that it'll also show you that this path is 5 minutes slower, 3 minutes slower. Sometime the difference is too large, half an hour, 30 minutes slower. Have you guys seen that in Google Maps?
Yes.
Yeah. So
Yes.
what these two paths are representing is the distance you will be covering when you go in these paths. There is path number 1 that you can choose. There is this path number 2, which you can choose. In both the cases, you will be traveling different length, isn't it? But what about your starting and ending point? Are they changing or they are same
No,
for both?
same.
They are same, isn't it? Yes. So you realized that the source and destination, as we can call them, A is the source, the starting point, and B is the destination. For the same source and destination, multiple distances can exist. There is not a unique distance between 2 points. Is that part clear? There can be multiple values of distance that can exist. Everybody fine with this? But what about displacement? Well, displacement is a unique quantity. Displacement has nothing to do with what kind of path is there, how many paths are there. It doesn't matter for displacement. Displacement is just concerned with source and destination. That's all. And that's why many a times displacement also becomes non-realistic for this reason. Because displacement just asks us, where is the source? We will say A. Where is the destination? We'll say B. And displacement will say, okay, then just join them. This length is displacement. Now, why it is many a times non-realistic? Because there need not be a straight path available like this between A to B. Many a times you put place in Google Maps, almost 99.9% of time, you will never have a direct straight road to travel there, isn't it? Most of the time you would have to take certain turns to reach there. So displacement is the shortest path. That's why we call it as the shortest path, because there is no bend, no turn in reaching from source to destination. Or you can also understand it as if it is like an aerial route. Whether the road exists or not, you can directly go through the aerial route there. While distance highly depends upon which kind of road you took. All right. So that's why the definition that the displacement is the shortest path between 2 points, while distance can have multiple values. Then what other points you've heard? You've heard that distance is a scalar quantity, while displacement, it's vector. Why is that so? What are scalars and vectors? Do you guys understand scalars and vectors?
So scalars have only magnitude and vectors have magnitude and direction.
Okay, magnitude and direction, both. Yes. So basically, in a very easy definition, which we can understand, is that vectors are the quantities where the direction is also important along with magnitude. While in scalar quantities, we don't care about direction. We just care about how much quantity it is, the magnitude. Take for instance, when you buy something, you measure the weight of it, right? You say that I need 2 kilograms of sugar. Now, you won't ask that 2 kilogram of sugar in which direction, east, west, or north. 2 kilogram is just 2 kilogram. There is no direction to it, isn't it? But when you talk about moving in certain direction, now direction matters. If you don't travel in the right direction, you may reach some different point. So that's why in vector quantities, direction is very much important, highly important. So why is it so that displacement is a vector and distance is scalar? You can understand it from this diagram itself. You see that displacement always has a well-defined direction. And what is that? Always start from source and end up at destination, like this. Always a direction, a defined unique direction. It will not even be from B to A. Always defined from source to destination. But look at distance. While you are covering distance, there is no predefined direction. There are many turns you are taking. Sometime you're moving like this. At other time you're moving like this. Then in this direction, then in this direction. Isn't it constantly changing? So when things are constantly changing, there is no predefined direction to it. That's why it's a scalar quantity, while displacement is a vector quantity. Fine. I hope this difference is also clear to everyone. Now you can understand about a very interesting case, that is when you choose a point A and you choose a point B. And best part is there is a straight road that exists between A and B. So could you explain the last point again? Yes, Vedant. So Vedant, what I was saying, that while you're covering distance, your road might have many turns, isn't it? Sometime left, sometime right, then sometime you move on a curved road, sometime you go even a U-turn and so on. Like that you reach at your destination, isn't it? So
Yes.
while covering your path, are you actually having a unique direction?
No, sir.
No, it's constantly changing, isn't it? But what about displacement? Displacement, does the direction change?
Single path.
It's always constant. It's a unique direction. And that is the reason we have said displacement to be a vector, having a defined direction, while displacement doesn't have a distance doesn't have a defined direction. All right. Is it clear now? Okay. Now I was taking a case where we have 2 points, A and B. And best part is a straight road exists between these 2 points. So ask yourself, if there is a straight road between 2 points, how will you like to travel? You would also like to travel in a straight line. So you will just travel straight from A to B. So now what you have done is the distance. You have covered a distance. But if I ask you what is the displacement, that will also be same, just a straight line from A to B. Yes. So we learned a very important point over here. And that point is, when we talk about a special kind of motion, and what is this special kind of motion? Straight line motion. That is how particle actually travel, in a straight line. So whenever we are having motion in straight line, or the topic we are learning, motion in one dimension means straight line. Whenever we are having motion in one dimension, then distance and displacement will be same. They will not be different. All right. And in all other cases, if let's say a straight road doesn't exist, then obviously the particle would have to come by traveling a large distance, isn't it? So we can put a very important point here, that distance is always greater than displacement. But just one scenario, it can become equal. And that scenario is for the straight line motion. So for straight line motion, it can become equal. Otherwise, for all other cases, distance will anyhow be greater. Is that part clear? Now, ideally, I should do one more thing. Ideally, I should not compare them directly. Why I should not compare them? Because one is scalar, one is vector. You cannot compare two different types of quantities. So I must immediately take the magnitude of displacement. That means here I am not considering the direction. I'm just talking about magnitude of displacement and magnitude of distance. That is what we are comparing. So we put a mod there. Mod simply represent its value we are concerned with, not the direction. So this is a fact which will always be there. All right. Others also clear with what we are learning? Okay. Great. So that was about distance and displacement. Now, based on distance and displacement, last part Vedansh want. Last part is this straight line one. So Vedansh, we discussed that when there is a straight line motion, then distance and displacement will always be equal, because you're covering distance also in a straight line and displacement is also a straight line. So they are always same. And in all other cases, distance will be greater. That's what we have written here. All right. Now, this is about distance and displacement, but there is always also about so this is distance and displacement. Now we want to talk about at what rate we can travel. Let's say source and destination are fixed between A to B. We have to travel. There are multiple ways we can travel. Let's keep our path fixed. Okay. We know that there is a straight road present between A and B. But two people are traveling. Person one, he's traveling there by walk. He's walking all the way from A to B. And person 2, he is traveling in a car. So distance, both of them will be covering will be same. That is the distance between A to B. Let's call it D. Both will be traveling the D distance. But can you tell me what will be the difference between them reaching at B?
Sir, time.
Yes, the time taken by them
time and speed
will be different, isn't it? Everybody agrees? Distance traveled by both will be same, but time taken will be different. Can you tell me if the person who went by walk took T1 time, person went by car took T2 time, which will be greater? T1 will be greater. Yeah. T1 will be greater. Car will reach very fast, so T2 is smaller. All right. So we learned a very important point, that why the person who is walking is taking large time, because we know his speed is slower. Because after all, what speed talks about? Speed talks about at what rate you're covering the distance, how fast you're covering the distance, isn't it? The same distance, two of them travel, but one takes a lot of time, one takes less. It tells you about the difference in the speed. So can you clearly understand here who is having greater speed and who is having smaller speed? Car is having larger speed, isn't it? If I write the speed of car S1, then S1 will be greater than, sorry, let's take it S2 because we've already given it. So S1 and S2. So quite clearly, S2 is greater than S1. Now, do you see a relation over here? Speed of second person is higher. That's why the time taken by it is lower. So what kind of relation is there between speed and time? Inverse relation, isn't it? We can easily write here that speed is having an inverse relation with time. That is first thing we understood. Let's understand another case. This time, source and destinations are not fixed. Both of them are allowed to start from A again. Again, the same person P1 who goes by walk. P2 who is going in a car. We tell them that, okay, you're free to move as much as you want. All we are doing is we are fixing the time for which you need to travel. Both have to travel for, let's say, 20 minutes. If both travel for 20 minutes, what will be the difference? What difference?
Distance traveled by car will be more than distance traveled by
Exactly. So what we will going to see is P2 would have traveled a very large distance in the 20 minutes, while P1, it would have traveled relatively very small distance. So this time I can call it D1, this we can call D2. So what we will learn over here, that D2 is greater than D1. And you know why D2 was greater than D1? Because speed of 2 was greater than speed of 1. Now, what kind of relation it tells you?
Direct proportional.
Direct proportional, right? We learned that speed is directly proportional to distance. And now if you combine the two inference that we have drawn, inverse relation with time, direct relation with distance, that is how you get the formula of speed. So I guess this is the first time you must have seen the logic behind the formula, why it is like this.
Yes, sir.
You always read it in the textbook, but never knew why they represent it like this. This is the reason behind it. It has inverse relation with time, direct relation with distance. So you guys may write down as you wanted to. We can put the constant as 1, Jayesh. Just like we do it in the equation F equals ma. Even in Newton's equation F equals ma, there is a constant k, but it is taken as 1. Okay, so everybody done writing? Okay, done. So this is about speed. Now you must have heard about another term called velocity. There's speed and then there is velocity. How can we talk about difference between them? What is creating difference between speed and velocity? The difference is created by the numerator. In speed, we are concerned with how much distance is covered in a particular time. But in velocity, what we are concerned with? We are concerned with how much displacement is covered in a particular time. Isn't it? How much displacement is covered? That is always important. And remember, among the two, if you have to talk about one thing which is more important, then it has to be the velocity. Speed may not be always the right information. I can give you an example to explain that. Suppose this is your source and this is your destination. If let's say you start from point A and you start to move at very high speed and your path is like this, you're traveling randomly. The path is having constant turns. Now think about at this instance. You have to reach at point B. But look at in this portion. The road was as such, maybe you took a wrong turn. You were actually supposed to travel to the other direction, but you took a wrong turn and now you are traveling in this direction. Now your speed may be very high. If I ask you that, what is your speed? You'll say, sir, it's very high. It's around 80 km/h. That fast we are moving. Now, no doubt you have a high speed, but does that ensure that you will reach your destination quickly? Will you be able to in this case? No.
No, sir.
Even though you have a great speed, but it doesn't ensure reaching the destination early. Why? Because you may be moving in a wrong direction. But if we talk about velocity, it has a predefined direction. Velocity will always see that whether you are traveling or you're covering this displacement or not. Displacement will always keep its direction towards destination. So only if you have a great velocity, you can be sure about that, okay, I am moving in the right direction. That's why velocity is the more important factor compared to speed. And obviously the reason is velocity has direction. It has direction, that's why it's more accurate. But what about if you're moving in a straight line? Will there be any difference between speed and velocity? If you go in a straight line, no difference, right? Because distance and displacement will have no difference. I told you that if you go in a straight line from A to B, straight road was available. You're moving in a straight road, then distance is also same, displacement is also same. So speed and velocity will also have same magnitude. For all other cases, if you're not moving in straight line, speed will always be higher than velocity. Why? Because distance will be greater than displacement. But having high speed does not mean you are moving correctly. Okay, now let's take a particular case and then we'll see what problem we are facing. So actually, I'm about to start with a new topic, but my way of teaching is not throwing the topic directly. I feel like we should understand why we are learning a particular topic. So first of all, students must be shown the need to learn that topic. And then when we see the need to learn, then present the topic. So you will also be having a better knowledge why we are learning this. So first, let me present a problem to you. Suppose the case is you start from your home and you reach your school B, and the path may be having many turns. That's how you finally make it to your school. And that day you were lucky enough to have the car. You went from home to school in your car. Now tell me, while traveling from your home to school, will the speed of car be constant?
No.
No, it will be changing.
It'll constantly be changing, isn't it? Initially, you might be moving with low speed, just 10. Then you got an empty road, so you accelerated really fast, 60 km/h you went. Then you got a red signal, so you completely stopped there. Then there was a light traffic, you moved with 20 and so on. Like that, you reached your school. Now, suppose when you reach the school and your friend asks you, okay, today you came in car. Can you tell me what was the speed with which you were moving? Will you be having any answer?
40 kilometer.
40? No, we cannot give 40 as the answer. Yes, the first problem you are understanding. The problem is that you were moving with various speeds. It was constantly changing, isn't it? So we don't have a unique answer in this case. What to do? So then we talk about a word that you have also used. Whenever such kind of question is answered, we say, well, it was constantly changing, but I can tell you on an average, I was moving with 30. On an average is the word we use, isn't it? So that is what we are learning. We understand the need of learning the average speed. We must understand the average speed first. All right. So what is average speed and how to find it? Well, I will give you the example of cricket. In cricket, you must have seen if it's a T20, so 20 overs are there, and a team has scored, let's say, 120 runs. So 120 runs in 20 overs. Sorry, 20 overs. So can you tell me on an average, how many runs are scored in every over? Yes. What will be the 6 runs would be the average run rate. And that is what the term that is used in the field of cricket, average run rate, isn't it? We say 6 runs are scored in every over. Does it mean that actually 6 runs are scored in every over?
No.
No, there can be various runs scored. Like there could be some maiden over also in this. No run was scored in particular over. In some over, there may be some death overs where 20 runs were scored in that particular. So number of runs may be constantly changing, but we give a unified answer that on an average, you can understand 6 runs per over. So average gives you an idea. And what was our method of calculating average here? The method was give us the total run, give us the total over, we'll divide. And that's the average. Same thing we can do here. For how much time you stopped, for how much time you traveled fast, for how much time you traveled with mediocre speed, doesn't matter. We are not interested what happened in between. We are just interested, tell us what is the total distance you covered. So I give you the total distance. Then whether you took a break in between, you were having something to eat in between, a halt you took, doesn't matter. Just give us the time when you started and time when you finally reached the school. Give us the total time. And that ratio is our average speed. Just following the logic of cricket. So I hope each one of you is clear with this. Okay. So I think it's time we do some questions on the topics we have learned. Let's take the average speed concept and let's try to do some problem on this. First, let's begin with very easy question. Suppose you are being told that a car started from point A, traveled till point B, and it traveled a distance of 20 kilometers. And it took some 0.5 hour to cover this. Then it went from B to C. It traveled a distance of 40 kilometers. And it took 2.5 hour to cover it. So what is the average speed of the car? S average. This S average is the notation for speed average. Yeah, 20 kilometers per hour is the answer everyone giving. What about people on YouTube? What answer you guys are getting? Same, 20 kilometers per hour. Okay, yes, it's correct. We just follow the formula. What is the formula? Total distance by total time. Here total distance is 20 plus 40, 60 kilometers. Total time that was taken 2.5 plus 0.5, 3 hours. That's 20 kilometers per hour. Easy as that. So first part was very easy. No problem in it. Let's now quickly jump to the second part. Car started from A, traveled all the way to B with a speed of 20 kilometers per hour. And it took a time of 1 hour in doing this. Then it traveled from B to C with a speed of 60 kilometers per hour and took the time of 2 hours to travel. What is the average speed in this case? That is not given, Vedant. You would have to think. So no, Jayesh. There will be a common mistake. Common mistake would be giving the answer as 80 by 3. People will say 20 plus 60, 80 by 1 plus 2.
20 kilometers per hour is the average speed.
Yeah, but that is the speeds given to us. So you would have to think something else. So yes, so Shreya has given one answer. Shri Pujita has given
240 kilometers.
Okay, let's see what the answer is. Let me also calculate in my mind. What will it be? No, Vedant. Distance will not be that. So far, I don't see any correct answer. Yes, now Arnav has given correct answer. The first correct answer has come up. Others, please give your answer. No, Jayesh, we are asking the average speed. Nope, all of you are giving me distance. Why you guys are giving me distance covered? I need the average speed. No, Shri Pujita, not right. Nope. No, Siddharth. No, Aditi. No, Kishore. Yes, Shreya, now it's correct. Yes, Jayesh, now you're right. Akhil, you're right now. Vedant, not. Vedansh is correct. Okay, so should I discuss how we should do this? See, we tend to quickly forget the formula. Yes, Aditi, you're right. We tend to forget the formula just now we learned. Formula is about total distance. We can't add the speeds, 20 plus 60, right? They are speed. First thing we should do is finding the total distance covered. How do we do that? Well, we are given speeds, right? Individual speed is given between A and B, and the time taken is given. So don't you think there is a way you can find the distance covered? Distance is speed into time. Remember? If distance is speed into time, then what will be the distance covered in AB part? So D1, if I call it, speed is 20, time is 1, that's 20 kilometer. What is the distance covered in the second part, the B to C part? There the speed is 60, time is 2, that's 120 kilometer. And so now you have the answer. It is the total distance, which is 140 by total time, which is 3. So 140 by 3 kilometer per hour. So I hope everybody is clear with this. 140 by 3 as the answer. So easy. So now I expect all of you to give me correct answer for at least the third case that I'm discussing. Let me put it up. Yeah, hopefully. In this case, we are being told that car travels from A to B, covering a distance of 60 kilometer, and the speed with which it travels is 20 kilometer per hour. Similarly, when it traveled from B to C, it covered a distance of 40 kilometer and traveled with a speed of 10 kilometer per hour. So for this case also, you're supposed to give the average speed. Okay, let me see the answer. Yes, Shri Pujita Siddharth, correct. Yes, Aditi, right, Shreya, Akhil, Jayesh, no Karthik.
100/7.
Yes. So I'm glad that for this case, everybody solved correctly. Everybody got the method to solve. This time, everyone was careful that we have not been given time. We have been given total distance. Can you all see that? Total distance is visible, 60 plus 40. That's 100. But we needed total time. So we can calculate from the first part, what is the time taken in the part AB? Time is distance upon speed. 60 by 20, that's 3 hours. Similarly, time taken in the second part, 40 by 10, that's 4 hours. So total time is 7 hours. 100 by 7. Everybody clear now how to do? Okay, how about we do some more questions? Let's do a few more. A car starts from A and is traveling with a constant speed of 30 kilometer per hour to the point B. And without stopping there, it just takes a U-turn from B. Just takes a U-turn and comes back again to A with a speed of 60 km per hour. So you have to tell me what is the average speed of the car in this entire U-turn journey. Question clear? Goes from A to B and immediately comes back from B to A again. It doesn't stop in between. No, Shri Pujita, that's wrong. Jay and Jainil, that's wrong. No, Vedant. Speed in onward journey is 30 and speed in incoming journey is 60. No, Vedanta, we are not finding distance. We are finding the average speed here. No, Vedansh, not correct. So this time nobody is correct. What is going wrong? No, Arnav, not correct. On YouTube, I can see Ebenazir, it's wrong. Ananya, it's wrong. No Jayesh, no Siddharth. So this question has taken everyone by a surprise. Nobody is answering correctly. No Saj on YouTube. No Jayesh. Yes, so Shreya got correct, Ankit got correct, Jayesh also got correct. So 3 correct answers finally. No Laksha, not right. No Saj. Yes, Shivank, you're right. So 4 correct answers so far. Rest of you think. See, the first common mistake that you might be doing is it's so easy, sir. Average, add the 2, divide by 2. 60 plus 30 by 2. 90 by 2 is 45. 45 should be answer. No, this is not how you find the average speed. So far, did I tell you method to find average speed like this? No, there is just one formula for average speed. That's all. The formula is total distance traveled by total time taken. That's the formula, not the mathematics or average. So follow that formula and you will never be wrong. So what is that formula telling you? This formula tells you that you have to calculate the total distance first. Let's say the distance between A to B is D. So can you tell me in this U-turn journey, how much is the total distance traveled by the car? 2D. Yes, D in going, D in coming back. So total distance travel is 2D. Now in denominator, we need total time. Let's see the time taken in onward journey, T1, going from A to B. What is time? Time is distance upon speed. Distance covered while AB is D and speed is 30. That's the time in first section. What about the time while coming back, T2? There also is distance upon speed, distance is D and speed is 60. So we got the 2 times. Let's substitute now. The total time would be D by 30 plus D by 60. You'll be like, but sir, D is not given. So who needs the value of D? You can clearly see it's getting cancelled, isn't it? If I take D common from the denominator, cancel it with numerator. This is what I'm going to get. 2 upon 1 by 30 plus 1 by 60. That's it. when you solve this, what will you going to get? So try, guys, those who did not get the answer, see what you're getting. Yes, so now I can see on YouTube also a few people have answered. Lakshya, Shanmukhi, Niranjan, you all got correct. Yes, and the answer is 40 km/h. So remember, average of speed is very different from average of mathematics. Physics is not math. It's completely different subject. All right, so I hope each one of you is clear. Let's move to a new concept, guys. So if average speed and all is clear, the new concept that we would like to talk about is equations of motion that you must have learned in your 9th grade as well. Have you heard about these 3 equations? Equations of motion. So there were 3 equations that you must have been taught. Yes, the equation namely V equal U plus AT, S equals UT plus half AT squared, and V square equal U square plus 2AS. These are the 3 equations that we learned. There is something special about these 3 equations, and that they all have vector quantities in them except time. Except time, all other quantities are vector. Vector means direction is very important. So that means while applying these equations, you have to take care about direction. And whenever you have to take care about direction, how you do it mathematically, you assign the sign convention. Remember, for mirrors also, it matters whether the object is on the left or right, image is on the left or right. So accordingly, we used to take positive, negative. Same thing exists over here, sign convention. While solving the questions of equations of motion, you must take one direction as positive and automatically the other becomes negative. Now there is no compulsion to take right positive. You could have taken the other way around. You could have taken left positive, right negative. That also works. Similarly, if something is thrown up, then you have to take sign convention for vertical direction, upward positive, downward negative. So that's about conventions. And while solving these equations, you must substitute every quantity with its sign, because that's how you'll mathematically differentiate. Think about it. How will this equation know if something is moving to the right or left? It'll only know it if it is positive or negative. That'll going to tell. Now you know what is U here. U is initial velocity, V is final velocity, A is acceleration, S is displacement. Very much important here. That S is displacement. T is time. So let's try out some question. First, let's do some easy ones. Okay. So easy one are like this. Suppose somebody starts from A at time 0. So whenever you are starting, you have your stopwatch. Stopwatch shows 0 at the start always. And the moment you start to move, you're going to click on that stopwatch. Suddenly the time would start ticking. So when you started, the stopwatch was at 0, and suddenly now you start to move with 20 meters per second. Stopwatch is also counting for how much time you move. It's given to you that this car which is traveling from A is under constant deceleration. Why it's a deceleration? Because see, I've drawn its direction in the left side. So this deceleration is not speeding up the car, it's slowing it down, isn't it? So car is constantly slowing down. Now you have to determine that after some time, the car would be found to move in this direction with 20 meters per second. With the same speed, it will be moving again, but in the opposite direction. When this happens, how much time will be shown by the stopwatch? When this thing happens with the car, how much time will be shown? Yes, Jayesh is correct. Others can see what they are getting. No, Jay, then it's just a fluke because it will not come from unitary method. Yes, Shri Pujita, you're right. Question is, Shambhavi, that car started at time 0 with 20 meters per second. It was constantly decelerating, right? As you can see, deceleration is to the left. After some time, car was found to move with 20, but in opposite direction. So after how much time this happened?
Okay, sir.
Yeah, so I can see 2-3 answer on YouTube also. I have seen there is one correct answer given by Ruchi. Here correct answers are given by Siddharth, Shreya, Shri Pujita is also given. Vedant, deceleration is opposite of acceleration. What does it mean? It means speeding down rather than speeding up.
Okay, sir.
Yeah. Yes, so Ankit is also right. Karen is right. On YouTube, I can see Shanmukhi sisters are also correct. 20 seconds would be the answer. See guys, this was a direct application of equations of motion. Which equation you will apply? Now, whenever you get questions of equations of motion, this is my suggestion to you. Always list down the quantities given to you. What is given to you? You are given initial speed, u. Yes, Jay and Jainil, you have also given. Let me check. I didn't receive. Can you send again? You got 20 seconds as well? Okay. So correct, Jay and Jainil. So yeah, always you guys have to list down what are the given quantities. Given quantities are initial velocity, which is given as 20. You've also been given final velocity, right? V. That after that time, the speed was 20. But did you notice something? The speed is to the left, final speed. That means, how should we take it? We should take it as negative 20. The final speed is negative. Final velocity is negative, I should say. And initial velocity is positive because that's to the right only. What about the deceleration, or I should call it acceleration? Even that should be negative because that is also to the left. Negative acceleration is deceleration. Deceleration is de-acceleration. That's the name for it. Now we have everything. We can just apply V equal U plus AT because we need the time. Let's substitute. V is negative 20. U is positive 20. Acceleration is -2. And we need the time. So this 20 goes on the other side, so it also becomes negative. And finally, we get 20 seconds as the answer. So after 20 seconds, car will have the speed of 20 again, but in the left direction. All right, that's how you solve it. A U symbolizes the initial speed at the starting point. Sir, we could use third equation of motion. No, Jayesh, how would we use it? We don't have displacement here, which is my next question to you all. Can you guys give me what is the displacement of the car in this motion? First part you all calculated. Now time for the second part. What will be the value of S, displacement? No, Shreya, that is actually wrong. Yes, Shri Pujita, correct. So Kishore, always give in private chat so that others cannot see the answer. So right now, I can't tell whether your answer is right or wrong. What is the displacement of the car? No, Ankit, that's wrong. Shambhavi, you are correct. Jayesh, correct. Akhil, you're correct. Shanmukhi sisters, you're wrong. You're giving on YouTube. Nope. Jay and Jainil, that's wrong. Shreya, now you're correct. Mrunay, you're wrong. Sorry, it's Mrunmay. Okay, so somebody named Kahan on YouTube is right. Siddharth, not correct. Ankit, correct. Laksha, correct. So the surprising answer is 0. The displacement of car will be 0. You can simply apply the equation. S equals ut plus half. What is the value of u? 20. What is the value of time? Also 20. Ut plus half a. A is -2. T squared. That is the equation. Everybody can check. I just applied this one. Ut plus half at squared. Here you could have used Jayesh. Here it could have worked. So here what is the answer coming up? This is 20 square, which is 400. And here there is 2 and 2 cancellation, negative sign, and there is also 20 square. So answer is 0. Whenever displacement is 0, what does it imply?
Then it is going to its initial position.
Yes, absolutely right. That means the car must have come back to the same position. But Jay, how would we know at the start? We are at the same point where we started. That only now we got to know that yes, since displacement is 0, that means the car has come back to the same point where it started. Everyone clear? All right. Now can you guys give me answer for the third part? What is the distance traveled by the car? Just now we learned the difference between distance and displacement. Now I am asking you distance traveled by the car. No, Siddharth, not correct. On YouTube, Ebenezer, you're not correct. So could you tell what is the given speed? Given speed at the start is 20 meter per second. No, Vedansh, Kishore is right. And Shri Pujita is wrong. No, Vedant, it's wrong. Ankit, it's wrong. Akhil is wrong. Jay and Jainil, it's wrong. Shambhavi, not correct. Okay, Akhil, you're correct now. Shri Pujita, not correct. Saj, we are finding here distance, not speed. Ruchi, you're not correct. Kahan, you're not correct. So this question has again went like a bouncer. Many people getting incorrect answer. Only 2 correct so far. Akhil and Kishore. Sure, Shri Pujita, let me do it. Here is the situation. No, Jayesh. So should I solve it, guys? No, Ankit. No, Shambhavi. No, Ankit. Not correct. So let's solve it, guys. See, the first 2 part were absolutely mathematical. Do you guys agree with that? In first 2 part, you were directly having equation to be applied. You were having the values, just substitute, get the answer. So easy. Not a big deal. The third question is a question of physics. I can say first 2 questions were a question of maths. Now we are having a question of physics. Distance we want to calculate. A common mistake. That is, array sir, distance also we have formula. Distance is speed into time. So just see the speed. Speed is 20. Time is also 20. So 20 into 2400. That's it. But that is wrong. Why? Because which formula you're applying? You're applying the formula distance is speed into time. You cannot apply that formula here. Reason, it's an accelerated motion. This formula is only valid for non-accelerated motion when speed is constant. You are substituting here speed. Distance is speed into time. I ask you, which speed will you substitute? Because that speed will keep on changing. From 20, it will be 18, it will be 16, 14. It's a changing speed. So which speed will you substitute? So we can't apply distance equals speed into time. So what we need to do now, we would have to think. Now for the first time, we would have to visualize what is happening with the car, which we were not doing in the first 2 parts. First 2 part was pure math. Third part is physics. So when people tell me that physics is nothing but math only, most of the time they're wrong. Physics is all about visualization. Without visualization, you can't do physics, even after knowing all the math. So let's visualize what is happening. First, we see car is traveling to the right. But where is the deceleration acting? It's acting to the left. Do you understand? Deceleration or acceleration means there is a force behind it. F equals ma. So that means car trying to move to the right, but somebody is pushing it to the left, creating a resistance. That's why its speed is going down. So what will be happening to this car? So gradually its speed will be decreasing. Right now it's 20, but later you will see its speed will become 10, then 5, 10, 15, 5, and finally somewhere it will become 0 as well. Why it will happen? Because it is constantly being pushed against its motion. Now, will it stop there at the 0 speed? Well, no, because the speed has become 0, but not the pushing force. Pushing force still exists. It's just like how you throw things up. If you throw a pen up, why its speed goes down? Because its speed is up, but it is pushed by gravity downward. So it goes up and up and up, and finally its speed becomes 0 at a point. Does the pen stop there? No, it falls back, isn't it? Why it falls back? Because the gravity is still pushing it in downward direction. Similarly, the force is still pushing it to the left. So now what happens? Car first of all comes to a rest, and now it moves to the left. So now the car will take a turn and start moving in the opposite direction. So now its speed will go from 0 all the way to 15, sorry, all the way to 5, then to 10, to 15, and it will become 20 again when it reaches the same point where it started. Just like when you throw a pen up, it comes back to the same point where it started. So did you realize that we can even answer the second part without any equation now? Since the car has come back to the same point, its displacement has to be 0. The second part, that is what we got, 0. Vedansh, car has come back to the same point it started. Just like when you throw a pen up, it goes up, stops momentarily in air, and then comes back in the same hand from where you have thrown it, isn't it? That is what has happened to the car. In the case of pen, there is a constant deceleration on it, which is the gravity. Here, we also have a constant deceleration of 2 meters per second square, pushing against its motion. You can just, do this thing upside down, and you will feel as if the pen is thrown up and it comes back. It's almost like that. All right, since the pen comes back to the same hand where it started, obviously its displacement is 0, isn't it? But does it mean that the pen did not travel any distance? No, it covered a distance. First it went up, then it came down. Same thing is happening with the car. First, it is traveling all the way to the right. It covered some distance d. And then it covered a distance to the left. That is also d. So why displacement became 0? Because one was plus d, other was minus d. Displacement has direction, isn't it? Vector. So plus d and minus d when got added became 0. But if we need distance, we should actually find 2d, 2 times d. Isn't it? No, Shri Pujita, not right. Is this part clear to everyone? That distance covered by the car would be 2 times d. Yes, Shreya, you're right. So how do we calculate the value of d first of all? So why don't you just calculate one-sided displacement? One-sided displacement means the displacement when the speed of the car went from 20 to 0. Final speed you can take as 0 for that particular point. And initial is 20. Acceleration is same, -2. And we need the displacement, one-sided. So just see what all things are given. Again, you are given u as +20. You are given v as 0. We are talking about the point where it stops momentarily. You have been given acceleration, -2. and you're required to find the displacement. Which equation perfectly suits here? There is no talk of time here. Nobody is talking about time. So which is that equation that doesn't have time? The third equation. Third equation doesn't have time. So you can just substitute. V square equal U square plus 2AD. Displacement is D this time. V is 0. U is 20 square. Plus 2A. A is -2 times D. So what is the value of D we get? 400 by 4. That's 100. Now, is this our answer? No. In JEE, there will be an option of 100 also. And in JEE, there will be an option of 400 also. The first answer that everybody gave. Distance is speed into time. So JEE tests you in every possible way. They test your presence of mind. Somebody solves all this and like 100, okay, let's mark it. But the actual answer is 2D, 200. This should be the answer. So that is about doing the real physics, visualizing what is happening, taking some analogy. Here, what helped us in understanding the analogy of throwing a pen up and then it comes back. Okay, so I hope everybody is clear with this. 200 meters is the answer. All right, guys. So this was some discussion on motion in 1D. Now we will meet again in the next class, whose schedule you will going to get, whose link also you will going to get. Don't worry about it. Okay. So that's it, guys, for the day. See you guys next time. Goodbye.
Thank you, sir.
Thank you, sir.
Thank you, sir.